remember how we defined the variance. The variance is equal to the summation of xi minus x bar to the second divided by n-1. And the numerator can be written as sigma xi squared minus sigma xi to the second divided by n. We're going to use this information and show that if you have n+1 observations, then n times the variance of n+1 observations is equal to n-1 multiplied by the variance of n observations plus n divided by n+1 times x sub n+1 minus x sub n bar to the second power. Let us begin. From left-hand side, n times the variance of n+1 observation based off of the definition can be written as the summation of xi minus xn+1 bar to the second. I starts from 1, goes to n+1. So this is just basic definition using what we learned before, which can be written as the summation of xi squared minus n+1 times x sub n+1 to the second. The reason for this is when you have n times the variance of n+1 observations, it is basically the summation of xi minus xn+1 bar to the second power. Well, here you have exponent 2, so you can write this in expanded form. The first term to the second power minus 2 times the first term times the second term plus the last term to the second power. And then we're going to take the summation over these terms. This can be written as the summation of xi to the second power minus 2xn+1 bar times the summation of xi's plus n+1 times xn+1 bar to the second power. Again, remember that the summation of 2xi xn+1 bar is equal to 2 times xn+1 bar. It doesn't have any I in it. You just need to take the summation over I. So that's how you end up with this quantity here. And then the summation of xn+1 bar to the second, since you're taking this over I starts from 1 to n+1. This is nothing but xn+1 bar to the second times the summation of i's starting from 1 to n+1, which is basically n+1 times the sample mean to the second power. Now, you can simplify this further. It is the summation of xi's to the second power minus 2 xn+1 bar times n+1 times the sample mean. This is basically the definition, plus n+1 times the sample mean to the second power. Again, you can rewrite this as the summation of xi's to the second power minus, here if you simplify these two, you have 2n+1 plus n+1, which gives you negative n+1 xn+1 bar to the second power. Again, this can be written as the summation of xi to the second plus xn+1 to the second minus n+1 times xn+1 bar to the second power. We just broke down this term into the summation of two expressions. Very good. This guy is equal to the summation of xi to the second minus nxn bar to the second plus nxn bar to the second. We just add and subtract this common element, and then we're going to use this later, and you're going to see why it is important. plus xn plus 1 to the second power minus, and the rest of it, n plus 1, xn plus 1 bar to the second power. Now, so far we saw that n times the variance of n plus 1 observations is equal to the summation of xi minus the sample mean for n plus 1 observation to the second, which can be written as the summation of xi's to the second minus n plus 1 times the sample mean to the second power. At the same time, the summation of xi's, I start from 1 to n plus 1, is nothing but the summation of xi's plus xn plus 1. But this guy can be written as, this is basically the definition of average plus xn plus 1. And so you can conclude that the average of n plus 1 observations is nothing but 1 over n plus 1. This is just following the definition. And now just substitute n xn bar plus xn plus 1 from the left-hand side here. You created a new formula for the sample mean of n plus 1 observations. Why it is important? It helps us to simplify the formula and get to the right-hand side. So first of all, the summation of xi squared plus xn plus 1 squared minus n plus 1 xn plus 1 bar to the second is equal to the summation of xi's. Remember that we just added and subtracted this quantity. And now you can write n times the variance to the second power as n minus 1 times the variance of n observations, basically the definition here, plus the rest of the terms, which is xn plus 1 squared plus n xn bar to the second minus n plus 1 times xn plus 1 bar to the second power, term by term. We can simplify this expression by substituting the expression that you see on top here. This gives you n divided by n plus 1 times xn plus 1 minus xn bar to the second. To see the algebra behind this, we're going to go to the next slide. So again, remember that xn plus 1 bar, or the sample mean for n plus 1 observation, is written as n xn bar plus xn plus 1 divided by n plus 1. Now, n times the variance of n plus 1 observations is written as n minus 1 times the variance of n observations. So it's just right here. Now for the rest of it, we're going to do the substitution and simplify it as much as we can. This can be written as n minus 1. We just copy down the very first term. We're not changing this. For the quantity inside the bracket, you have xn plus 1 squared plus n times the sample mean to the second minus n plus 1. And then now for xn plus 1 bar to the second, use the quantity that you defined here, but it is raised to the second power. So you're going to multiply this by itself twice. At this point, you can cancel out the common factor n plus 1, and it becomes n minus 1 times Sn to the second plus xn plus 1 to the second plus n xn bar to the second minus n xn bar plus xn plus 1 times itself divided by n plus 1. Well, here you can take common denominator and then simplify it further. You can multiply these two, just basic algebra, and then taking the common denominator gives you the following expression. You multiply n plus 1 by xn plus 1 to the second and divide it by n plus 1. The same for n xn bar to the second. You multiply by n plus 1 divided by n plus 1. And this guy already has n plus 1 as its denominator. Then you try to simplify this as much as you can. So here you get n xn plus 1 to the second plus xn plus 1 to the second plus n squared xn to the second, basic algebra, plus n xn bar to the second minus n squared xn bar to the second minus 2 xn plus 1 times n times xn bar minus xn plus 1 to the second. And you divide everything by n plus 1. Try to simplify as much as you can. So we're looking for the opposite terms. You have n squared x bar to the second, opposite here. And then let's see. You have negative xn to the second, which is just right here. And then you have n xn bar to the second power minus 2 xn plus 1 n and xn bar. After simplifying the whole thing, it becomes, let me just erase this so you have enough space. After simplifying the whole thing, it simplifies to n divided by n plus 1, xn plus 1 minus xn bar to the second power. So again, you can just do the algebra and see the result. So that's how we prove this formula.